Okay. And then your homework, most of your homework for this chapter is going to come from worksheets. I like the book to like on a few sections, but most of what I like you to do is on these worksheets. So, all right. Recall with me, it's been a while, I know. We had f of x equal to x cubed or x to the fifth or x to any power. This is called a power function. And remember, this was that cubic, remember just disco? Right, x cubed. That's what we were working on in chapter 2. All of the power stuff, that's all we did. X to the fifth, what does that look like? X to the fourth. And they all follow the x squared and x cubic. Well, we're changing this up a bit. We're switching these two now. Now you are going to be introduced to like 3 to the x power now. When the x is the exponent, that's called exponential function. When the x is your exponent, that's an exponential function. When x is the exponent. And now the proper way to write it would be f of x equals, they actually have a number coefficient in front times b to the x, like that. For this one, my a is 1, my b is 3, and that's my x. But that's, when your x is the exponent, it's called an exponential function. So first part of your homework tonight is we're just going to graph them. I mean, which is great. You got a graphing calculator, but you need to see what they look like, and you need to remember all that fun stuff from chapter 2 and the translation. So we're going to graph them. You have a calculator to do it, but let's look at a few examples. Y equals 4 to the x. Let's compare that to y equals 4 to the negative x. And without using your calculator, let's just see if we can kind of figure this out, like make a table of values. Bless you. I usually like to do -2, -1, 0, 1, 2. And let me start from the bottom here. If x was 1, what would your y be? If x was 1? 4, right? 4 to the 1. Why did I write it like that? Why am I a moron? Lord of mercy. Shoot. Okay, there we go. If y was 2, what's 4 to the 2? What's 4 squared? 16. If 4 was 1, if x was 1, you'd be 4. What if x was 0? What's anything to the 0 power? What's 4 to the -1? Do you remember doing that way back in September? 4 to the -1? 1/4. It's 4 to the -1. And what would 4 to the -2 be? 1/16. Okay. So if you start graphing this, here's 2, here's -2, 0, 1, 2, 3, 4. 1, 4 is like right there. 2, 16 is way up here. I mean, way up here. I can't even, actually, it'll go off. And then at -1, you're at 1/4, which would be like here. At -2, you're even tighter along that x-axis. So your calculator might make it look like it's actually touching the x-axis, but we know, because we're smart children, we're never going to touch this x-axis, are we? No, that's like an asymptote right there. It gets very, very close. The end behavior, remember that word? We've learned all this stuff. The end behavior of this does approach 0, but it doesn't touch 0 because that's an asymptote for us. Now, come with me, and do you know what would happen here? What would be the difference between this graph and now this graph if I have a negative x? Where would it flip? Over the x or over the y? It would flip over the y. Okay. And if you can check this out, plug it in your calculator, but that when you are inside the parent, you have a negative, you flip over the y. If you're outside the parent, you flip over the x. So this would actually go, it would pretty much look the same thing except go like that. Okay. And I mean, if you want to draw a table, you can for that one, etc. All right, let's move this up. And again, I know you've got a calculator tonight, and I would like you to use your calculator for all these, but I kind of just want to talk you through this because I just want to see how much you remember, to be honest with you. I'm taking my 4x, right? This is my parent function, 4 to the x. Now I'm putting a 1/2 here, and I'm putting a +2 out here. Anybody remember what that +2 does? And it goes up 2. When you're outside the parent, you shift up 2. Anybody remember what that 1/2 in front does? Yes, it vertically stretches it, okay? And again, you can obviously go on calculator and punch this in. When you punch this in, by the way, you're going to want to put this in its own parentheses. Yes? And then put 4 to the x, and then make sure, you might even want to put this in its own parentheses, put +2 outside. So you need to see this graph go up to, so where is it actually going to intersect on the y-axis? It's going to go through 1, 2. It's going to go up to 0, 3. Would you agree? So it's going to look like this, 1, 2, 3. And it's just going to be like a little bit more stretchy. A little bit more. And you can see that. Let's do one more here. Y is less than, and I changed it to the x plus 1. All right, I want to make a table only because I just think it's good to look at the tables as well. And again, when I make a table, I do -2, -1, 0, 1, 2, except for that one where I switched it because I'm a moron. Okay, so let's work with positives. If I have 2 to the second plus 1, 2 squared plus 1, what is that answer? 2 to the second plus 1. What's 2 squared? 2 squared plus is 4 plus 1 is 5. All right, now plug in a 1. What's 2 to the 1? 2 plus 1 is 3. What's 2 to the 0? 2 to the 0 is 1. 1 plus 1 is, there's your y-intercept. 2 to the -1 is a half. Yes? 1/2 plus 1 is 1.5, 1.5. 2 to the -2 is a fourth. 1 plus a fourth is 1 and 1/4. And so when I graph this, because I want to be a little bit more accurate here, so let's see, 0, 2, 1, 3, 2, 4, 5, like that. -1, I would be at 1.5, and -2, I would be at 1.25, 1.25. Where's my asymptote there? Where's my end behavior leaning toward? Am I going to go past this right here? Right? I'm never going to get past 1, am I? Mm-mm. Do you remember with less than, what kind of line you make? It's dashed. Do you remember that? Yeah. Okay, this is dashed. And you have this asymptote right here at 1. Why is that? Well, you shifted up 1, so obviously you have an asymptote. Do you remember how to shade if your y is less than? Underneath. You shade underneath. So that's what that graph would look like.
Is that dotted line so awful?
That's a dotted line. I know, yeah. So it probably looks like a terrible dotted line. Dotted line. All right. So again, you'll have, this is your first part of your homework tonight. Oh, this is so hard. I know. You're crying. Stop the tears. All right, let's move over. Now we're going to do, last couple things here is this new number. I don't think you've seen it before. Maybe you have seen it before. I don't know. We're going to find out. See if Amy Davis taught it to you. Have you heard of the number E? Not the letter E, the number E. Have you heard of that before? No. Okay, I just want to let you know it is on your calculator. If you look at where it says ln, right above it, it says e to the x. If you can kind of see mine right here. Okay, just so you know, it is on the calculator. So I want you to type in e to the 1 because I want to find out what e is actually representing. What is e to the 1 equal? Do you see that? 2.718281828. Okay, I hate to tell you your calculator is misleading to you because it looks like it's repeating, doesn't it? It's not, okay? In mathematics, E is irrational. It's an irrational number, like our good old favorite pi. Rational numbers are numbers that are decimals that go on forever and they never repeat, ever. So that's why your calculator, unfortunately, is misleading you because it's rounding at the end. But E is actually made up of this algorithm here. They took the number 1 and then they added 1 over 1, then they added 1 over 1 times 2, then they added 1 over 1 times 2 times 3. I know it seems weird, but this is what they're doing. 1 times 2 times 3 times 4 plus on and on and on and on, and they kept adding. So that's why it's this decimal that gets on forever and ever. It is roughly equivalent to 2.718, but it does keep on going and it never will repeat, even though it looks like on your calculator it's repeating. Your calculator is rounding it, okay? It's just like pi, 3.1415977, and it goes on and on and on, okay? Now, just like pi, we celebrate pi on March the 14th. Did you know that? Do you know when we celebrate E-Day? February 7th. What? No, no one cares. I know. Don't worry. I'll remind you on February 7th. It's E-Day. And you're like, I don't care.
Wait, when is pi? When is pi day?
What is pi?
Oh, okay.
Okay. She goes, oh, okay.
I'm so stupid.
Okay.
Wait,
Now.
Can we have pi on pi day?
Yes, Sierra. I know she hasn't been here. She didn't have Amy Davis. It's okay. We'll help her out here.
Oh my.
We have a whole big pie salute.
Oh.
All right, we are going to graph e to the x because e is, again, a number. E is a number. No, Mrs. Sutter, it's a letter. No, it's a number. Okay, in your brain, in this classroom, e is a number. It is just like 4 to the x. It's e to the x. It's 2.718 whatever to the x, okay? So we're going to graph it, and I'll even let you, put it in y equals, clear. E to the x, zoom 6, that's your best friend to go back to. Do you see how my calculator looks like it's stopping right there? Or maybe it's starting right there? It's not. The calculator is misleading you because it doesn't understand how close to get to this line. So it'll just make it start at something that they think this is a good place to start. But remember, it's getting very tight to that x-axis, okay? And you can look at the table, obviously, if you remember how to do all that. Table. These are very, very small decimal numbers. But going back to the graph, let me just explain what you're doing. I actually do want to draw a table. How am I doing on time? What time am I done here? At 45? Oh, yay. Okay, we got time. Yay. Okay, so -2, -1, 0, 1, 2. Those are my favorites to go to, my go-to people. Okay. And this middle, you'll see what I'm doing in a minute. This is e to the -2. E to the -2. Anybody want to tell me mathematically what is e to the -2? I got 0.135. Is that what you got?
Yeah.
Okay. E to the -1, same as 1 over e. Anybody want to tell me what that is?
0.36.
Good. This one we should all know. What is anything to a power of 0? 1. This one is e to the 1. What is e? I just told you above. Look at your notes. 2.718. This is e squared, which would be 7.38. Okay. So when I go to graph this again, you're at -1, -2. You are at -2. You're very, very tiny, very, very close to that axis. And again, at -3, you're even tinier. It's very, very tight right here. At -1, you're still pretty tiny. At 0, though, you're finally 1. And then at 1, you are e, which is 2, 3. You are like right here. And then at 2, you're about 7. This point right here is coordinate 1e. That's what we would call it, 1e. Okay. And then you'll have to do, obviously, some things on homework tonight. Again, you have a calculator that will be like, what's e to the x plus 1? Oh, well, then that's this graph. Shift it up. You know, what's negative e to the x? Oh, that flips over the x-axis, going back all the way to what you did in 2. I know it's been a while, but again, you have a calculator, so don't freak out about that. All right. Why do we talk about e here? Because we're going to do 2 last things. E is used in business a lot. If you're going to be a business person, be accounting or whatever, you have to do what's called compound interest and compound continuously. So you are going to have to memorize these formulas. This is the formula for compound interest. A equals P times 1 plus R over N to the NT. I'll explain all that in a minute. And then you have to memorize this formula. This is the compound continuously. Continuously. This formula is, it's probably my favorite one. It's called a PERT. A PERT. A PERT. Now, I'm going to explain what each one of these means. We're going to do an example from your homework on this, and that's it. We're done for the day. Okay. So if you are, I mean, you all are juniors, most of you, some of your seniors, you're going to probably be taking out student loans, okay? Student loans use compound interest. Buying a car, doing a mortgage payment, compound interest. It's so much fun. So this P stands for principal, or I like to think of it, the amount you put in. For a loan, it would be the amount that you're taking out, I guess I would say. But for a savings account, you know, grandmama gave you $5,000 and you put that into the bank. That's your P, 5,000. For your student loan, you know, oh, I got to take out a loan of $30,000. That goes there. Yes, just you wait. Okay. R. Anybody have an idea what R stands for? The rate. Now, your rate needs to be written. It will be given to you as a percent, but you need to convert it to a decimal. You need to make, so if it's 2.5%, move the decimal place over twice, 0.025. You always move it over twice. Beyonce gave us a great song, to the left, long time ago. That's how I would always teach my children back in the days. Oh, back in the day. T represents time. Time is always measured in years. So if you were only going to take out a loan for half a year, you would point 0.5 here. Okay. Or if your person says, oh, I'm only going to take it out for 3 months, well, that would be 0.25 of a year. Okay. Am I going to confuse you like that? No. Normally they don't.
So when you take out loans, you give them an estimate how long it's going to take you to pay it off?
Yes, they will give you a time frame. The A is the balance left in the account. So how much interest was paid on that. And then this last thing is this N. What does this N mean? This N is important. This is the number of times it was compounded, the compound times. That's what they call it in a business sense. So if they want you to take out a loan annually, your N would equal 1. If they want you to take it biannually, do you know what N would equal? If they want you to take it out quarterly, 4 quarters. Let me think what else they do. Monthly, you take out a loan monthly. Compounded monthly, you would do N to be what? 12. They could give it to you daily. That's terrible, by the way, unless actually you're gaining interest on it. But if you're paying back the loan daily, what's daily, everybody? $365. And then they could even do, I hate to tell you, hourly. That's horrid.
The more money you take out, the more they're going to make you pay it. Like, So say I took out $30,000 versus 20,000.
Your 30,000 student loan, honey, you are probably going to be paying more than $100,000 at the end of your term. Welcome to the real world. Hourly is, I don't know, it got canceled. I think it's $87.60, maybe something like that. I don't know. Okay. APERT, you only use APERT if it uses this phrase right here continuously. That's the only time you do not use this one. You use this one. Okay. If it says continuous, your P is still principal, same thing. This E is the magical number in your calculator that I just showed you, right? 2.718. What do you think that R is? The rate. They're going to give you a rate. T, time, still going to be the same. You just don't have to deal with this N stuff anymore, okay? So now we're just going to practice some of these. And then we're done. And this is your homework. And yes, you have to do all of them. Actually, let me see what Okay, so you are, obviously use your calculator, graph these for me. Just graph these. I tried to make some, if they go off the grid, I'm sorry about that. I tried to, here's some E's, graph your E's. This isn't hard, right? 1 through 8, you can do that. We're gonna do a compound interest in a minute. And some of them you can't do. And then obviously, I do want you to try these last 4 problems on the back. But you are actually not, you're gonna cross off on this side right here, which says compound interest, 2, 4, 6, 8, and 10. You're welcome. That's what I want to hear. Okay, and we are going to do, well, real quick, I'm just going to start you off on one of these right now. Okay. Good old Brenda, she wants to invest $48.48 into a savings account with a fixed annual interest rate of 5% compounded 2 times per year. What will the account balance be after 6 years? Okay, so did you see the word continuous at all?
No.
Then you don't use APERT. You use this guy, A equals P times 1 plus R over N to the NT. You'll memorize it, don't worry. So what is the P? What is she putting in? 48.48. Oh, can't do it. Times 1 plus, what is my R?
0.05.
0.05. You always move the decimal over twice. N compounded times, what would be the compounded times? 2 to the power of N times T. So what do I do? 2 times 6, which is, do you all agree? 12. When you go to put this in your calculator, you got to be really careful about this, okay? You would go 48, parenthesis, you can do 1 plus. I would put an extra set of parentheses right here. So I would actually go parenthesis 0.05 divided by 2, close it. Because if you don't, what the calculator will do, it'll just add the 1 and the 0.05. It doesn't, and then it'll divide that whole thing by 2. That's not what you want. You just want the 2. You could have put what, 0.025 right here, right? Cut that in half. And then raise it to a power of 12. Do not give me this answer. You always give your answer in cents, which means to how many decimal places. So what would be my answer? 6,520 point. So if I invest $4,800 at the end, I would actually make about $6,500 total. That's pretty good. Okay. But again, think of that in terms of loans, kids, for all of you